Hey guys, happy Thursday. So of course I'm not there. I'm out at meetings all day today. So today you guys basically know how it works. We're gonna run through the video together, and you guys have your class activity at the end. Now here's the only difference. I'll make sure you guys pay very close attention. You're gonna take your notes. Okay, you're gonna do one on the front side of your piece of paper, and when you get to the class activity, I want you to do it on the back side of that paper, or a separate one if you need it. But you're turning both in today's notes and today's class activity together into the inbox when you guys are done. All right. So make sure you guys follow along with the video and you guys listen to my instructions, all right? So get started on the warm-up like you normally do, and then hit pause and then hit play when you're ready to go through the solutions. All right, guys, so here we go. Let's go through the warm-up. Now, solving a multi-step, I see parentheses here, so let's distribute -3. We get -3 times x is -3x. Well, what is -3 times 4? That is -12. I'm going to bring everything else back down. Okay, now I notice that I have variables on both sides, so I'm going to get them together on the same side. Let's get rid of -3x by saying +3x. Whatever I do to one side of the equal sign, I got to do it to the other. So 6x and 3x gives us 9x plus 7 is equal to -12. All right, the next thing that I have to do is get rid of 7. So let's do -7. -7, these guys will cancel out. I get 9x is equal to, now they're both negative, so -7 and -12 give me -19. Now the last thing that I have to do here is divide both sides by 9. So x is going to equal -19 over 9. That is our final solution, and that is it. Alright guys, so today I told you guys you're going to get a little bit more practice on multiplying binomials by binomials, so make sure you guys title your notes. Remember, you're going to turn these in with your class activity today. That's a big difference for today. I'm collecting both notes and your class activity. All right. So yesterday we talked about two different ways. And again, I don't care which way you use, okay, as long as you can multiply a binomial, two terms, times another binomial which has two terms. You can use double distribution over here. Okay, distribute the first term and then distribute the second term. And of course, you always want to combine your like terms if you have any, like we do here in the middle. If you're going to use the Punnett Square, just like biology, right? Break apart your terms. And then how do we get the inner pieces? We're going to multiply. So, for example, here 2x and 5x. 2 times 5 gives you the 10. And then don't forget, x times x is x to the second. This little guy was giving a lot of people trouble all day yesterday, so just watch out for that. Okay, so let's jump into our actual examples. I have a few examples for you guys here. So pause the video here. All you have to do is pick one and try it out. When you're ready, please hit go. All right, guys, so I'm going to do both of these problems here. I'm going to start off with standard met. Now I'm going to use double distribution for this guy. So let's go through and do x times x. Well, x times x, remember, there's x to the first, and x to the first is x to the second power. Now I'm going to go to x times -3, which is -3x. Cool, I'm done multiplying the x, so I now have to distribute the 4. What is 4 times x? That's going to be a positive 4x, and then lastly 4 times -3 is -12. Now the nice thing is this is already in standard form. All I have to do now is combine my like terms, which I see here in the middle. Now be careful. -3x positive 4x is going to give us a positive 1x, or simply x. Now don't forget, what do I do with the -12? I can't combine it with anything, so it gets brought down. I can't do anything with the x squared, so that also gets brought down as well. That is our final answer there. X squared plus, if you want to throw in the 1, you can, -12. All right, let's go over here to beyond standard. So same thing, but I'm gonna use the Punnett Square on this guy here, so we can get comfortable doing both methods. All right, there's my Punnett Square. Now again, across the top here, I'm gonna put my first and second term, so 3x, and that is a -9, so watch out with that. Okay, down here on the side, I'm gonna put -6x. That's a -6x, and that is a positive 2. All right, now how do I get the stuff on the inside? I have to multiply straight through. What is 3x's times -6? Well, 3 times -6 is -18. Now, x times x is x to the second power. Again, watch out with that exponent. Well, let's get this box here. -9 times a -6. Negative times a negative is a positive 54x. How do I get this piece here? That is 3x times 2. 3 times 2 is 6. X doesn't have anybody with, so we just drag them down. Now, what's -9 times 2? That is -18. All right, I got all my terms. Now it's just to put it in standard form and combine our like terms. Well, the standard form says x squared is going to come first, so it's negative 18 x squared. Now again, that couldn't combine my thing, so let me get rid of it. Now I see that I have 54x and 6x. Well, 54x's and 6 more x's is going to give me positive 60x. And of course, negative 18, your constant, doesn't have anybody to join up with, so we just drag them over here at the very end. That is our final answer. And again, if you're getting comfortable with this, good. This is, again, I told you I would rank this as one of my top 3 standards for Algebra 1, like your top 3 need to know things. This would be one of those guys. Same deal, guys. Pause the video here, and when you're ready, hit play, and we'll go through it. All right, so let's go. This time I'll start off with standard met, and this time I'm going to use Punnett Square for this guy. Why not? I'm going to change it up a bit here. Okay, I'm a big fan of the Punnett Square. It's just going to help out a lot more when we start going backwards with these types of problems. So let me write in 5x, my first term. My second term, that's not just a 1, it's a negative 1, so watch out. I have 4x sitting on the left here, and right below it I have a positive 3. Now let's go ahead and fill it in by actually multiplying. You're secretly doing distributive property here. 5 times 4 is 20. Now x times another x is x to the second power. That's going to become important in a second. Well, what's negative 1 times 4x? That's going to be negative 4x. What is 5x times positive 3? That is positive 15x. And then lastly, what's negative 1 times 3? That is negative 3. All right, let's combine our like terms, put this all in standard form all at once. Let me get a different color here, green. So the 20x squared should come first. It's the highest exponent, not just because it's a 20, but it's x to the second power that makes it go first in standard form. Okay, which ones can I combine now? Well, my like terms are right here in the diagonal, which is kind of nice with Punnett Square, right? They don't normally line up like that. Well, this is 15x, and that's a minus 4x. So what's 15 and a minus 4? Be careful there. That's going to give us 15 minus 4 is 11x. And the last one, your constant, is just minus 3. That has nobody to join up with. So that is our final answer. For beyond standard, let's go ahead and do this with double distribution. What is 5x times a 5x? 5 times 5 is 25. X times x is x to the second power. All right, done with that. Let's go with 5x times now positive 7. Well, 5 times positive 7 is positive 35. Not just positive 35. Don't forget about the x as well. Okay, let me go ahead and do it. Now this time, careful, this is a negative 7. Negative 7 times 5 is negative 35x. Negative 7 times positive 7 is negative 49. And again, it's in standard form, which is nice when you do it this way. But I still have to combine my like terms. And I notice that I have a positive 35x and a minus 35x. Now this is a little awkward. If you have positive 35x's and then you take away 35x's, well, you're left with no x's. So should I even bother putting an x here? No, because we're going to assume that there's a 1. So these guys actually end up canceling each other out. So let me bring down what I'm left with, the 25x squared. And then this is a negative 49. That is it. So again, it's kind of weird, right? We're normally used to getting a trinomial as our product at the very end. But this time your middle terms ended up canceling out. So I end up with the binomial. All right. Let's move on to example 3. So again, pause the video here. Now watch out. If you're going for beyond standard, careful. All right, I'm going to step it up here. This is a binomial times a trinomial, but it should still work out the same way. You just have an extra term that you have to multiply. So again, pause the video here, guys. Try it out. All right, so let's do both of these with Punnett Square. Let's check this out. Let's see. Here's our Punnett Square. And again, across the top, I'm going to use my negative 4x. Oops, I almost put positive 4x. Negative 4x. That is a negative 3. Now going across, going down, I see that I have an x. And a lot of you guys like to put a 1x, which is cool. Go for it. And then this is a positive 7. So I'll put positive 7 down below there. All right, let's fill in. Okay, negative 4x times positive 1x. Well, negative 4 times the 1, remember you're multiplying to get the product in here. Negative 4 times 1 is just, well, negative 4. Now an x times an x gives you x to the second power. Okay, let's do negative 3 times 1x. Well, negative 3 times 1 is negative 3. Don't forget about your x. 7 times what? Times negative 4x. 7 times negative 4 is negative 28x. And then lastly, negative 3 times positive 7. That is negative 21. All right, now I'm going to go through and write my final answer here. Well, negative 4x squared should come first. Okay, combine your like terms, combine your x's. Negative 3x and negative 28x gives you negative 31x. And then the last one's going to be negative 21, which is just your constant, and that's it. There we have it, binomial times a binomial. All right, now again, beyond standard, this is what's we're actually gonna get here next week. So again, if you got this one right, okay, good on you. You're ahead of us. Let me catch up here. So for this one, again, if I do a double distribution, it's gonna get a little messy. So my thing here is I'm gonna do the Punnett Square. Now, when I do the Punnett Square, it's actually not gonna be a Punnett Square. It's gonna be a Punnett Rectangle. So what do I mean by that? Well, here we have my 2 columns, and I'm going to need 1, 2, 3 rows. So across the top, I'm still going to put the x. I'm still going to put the negative 3. I still want to break up that binomial. But when I go down, okay, on the side here, I'm going to put my 3 terms for my trinomial. This is going to be 2x to the second power, a negative 5x, and that's a positive 3. And it works the same way, guys. All you really do have in this case is just an extra row. You have to multiply 2 extra things. All right, so it's not too stressful, not too crazy. But now let's be careful again when we multiply. What is 1x times 2x to the second? Well, 1 times 2 is 2. Okay. Now what's x to the second and x to the first right here? Well, that's going to be x to the third power. So watch out with that. All right, let's go ahead and do negative 3 times 2, that's negative 6, and it's going to stay as x to the second power. There is no other x's to multiply with. Let's move down here to the next row. What is 1 times negative 5? That is negative 5. Now be careful here. X times an x is x to the second power. What is negative 3 times a negative 5x? Negative times a negative is a positive. 3 times 5 is 15x. Let's go down here. What is 1x times 3? That's just going to be 3x. And lastly, guys, what is negative 3 times a positive 3? That's going to be negative 9. So I have all my terms. The nice thing is that they're all nice boxes. Everything's organized here. It's just I have to collect these guys nice and neat together here. Okay. So what should this actually turn out to be? Well, let's start off with the biggest exponent that I see, and that's going to be 2x to the third power. So I'm going to write, actually, can I combine any other x to the thirds? Nope. That should be the very first guy that I write. Okay, done with that guy. Okay, I'm going to move on to the next highest exponent, which in this case is a 2. Can I combine an x to the second with anything? Yep. There's another x to the second diagonal from it. So negative 6x squared and a negative 5x squared give me negative 11x to the second power. All right, took care of those guys. Bam, they're done. Okay, let's move on. We went from a 3 to a 2. Let's go to just a single x. I have 15x. Any other x's? Yep. Check that out, diagonal, which is kind of nice, right? Your like terms are lining up like that. 15x and 3x is going to give us positive 18x. And then lastly, of course, the negative 9 has nobody to join. He's the last constant, last term there. That is our final answers. That's a binomial times a trinomial. So if you got that correct, good, 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 good. If you're on the right track, good. Again, this is what we're going to lead up to next week. That's kind of as hard as they're going to get, a binomial times a trinomial. All right, guys, I'm going to skip here to your class activity. Again, you're going to turn in your notes and your class activity both into the inbox again. You can do it right on the back of that, or if you need another paper, that's fine. Just make sure you staple both pieces together. You are multiplying, guys, binomials by binomials. Again, watch out with the first part. X times x is x to the second power. I'll see you guys tomorrow. Have a great, great, great day.